consider the differential equation given. Let's consider how to identify the slope field corresponding to the given differential equation. You may do the next. You may consider dy over dx to be equal to 0. An equation arises and you need just solve this equation. Here we can see that the fraction is equal to 0 and the possible solution is when numerator is equal to 0, so a solution is x is 0. And what is the graph of this solution x is 0? X is 0 is just a vertical line through x is 0 or just y-axis. But what does dy over dx mean? dy over dx, it means a gradient over tangent, and derivative at the point, it means gradient over tangent to the curve y over x, which is a solution to a given differential equation at a given point. And everywhere where x is 0, there must be horizontal tangents. And such pattern is for C. So for A, the answer is C. And in general, solution to dy over dx to be 0 may be of the form y is mx plus c. So you may just plot a line, and everywhere on this line there must be horizontal tangents. Or solution may be of the form x squared plus bx plus c, and graph is a parabola. So you plot a parabola, and everywhere on this parabola there must be horizontal tangents. And for opposite problem, if you need to plot solution y over x, a curve y over x, and this dy over dx to be 0, it gives us a point where a curve can have a turning point or turning points maximum or minimum, and only here. A curve in general, a curve may be like this, but it cannot be like this at all. It cannot have a maximum or minimum somewhere else. The next, right, find an expression for y in terms of x for this solution. So we need just solve this differential equation. Dy over dx is x over e to the power of 2y, and we use a method which is called by separating variables. We need everything with y to be, for example, to the left, everything with x to the right, or vice versa, it doesn't matter. And how to do that? We can multiply both sides by e to the power of 2y and then by dx, or fraction is equal to another fraction, it's called a proportion, and we can move factors along a diagonal. E to the power of 2y moves to the left up, dx moves to the right up. So we get e to the power of 2y dy is equal to x dx. And then integral. And what about this integral? You can see that it looks like e to the power of y, but y is just multiplied by a number, and such situation is called when function is of ax plus b. What does it mean? We know that integral of e to the power of x dx is the same, but if function of ax plus b, it means that integral of the form ax plus b, where a and b are some numbers, for example 2x plus 5, and so x is multiplied by some number. It may be 1 in general, so it may be just x plus 5 or something like that, and may be plus minus another number. And we use the same formula as given in a data booklet, keep the same argument, but 1 over a arises in front. Otherwise, you should use substitution u to be 2y here, but here you can see that it's if you consider e to the power of y, it's a function of ax plus b. You can see that y is only multiplied by 2. So we use the same formula, e to the power of y, the integral is the same, we keep argument, but 1 over a it's a number which is multiplied by y. Here arises in front. Is x integral, it's x squared over 2 and plus some constant. We write constant only on one side. And we can multiply, it's not necessary, but we can multiply each term by 2 to get 2c, but 2c is just another constant to be found. Let it be a, for example. Then finally we need it to be of the form y is. So what should we do here? We can apply ln. Why? Because there is such a property that and in general it may be log to any base, so log ab to the power of c, it's c log ab, and if we apply ln, we get the next. Ln of the left hand side is equal to ln of the right hand side. And notice that there is a constant, but it can be found because it is given that when x is 0, y is 0, we can find it now or later. It doesn't matter in general, but let's find it now and then apply ln. When x, it is given when x is 0, y is 0, just substituting 0, 0, we get e to the power of 0 is 0 plus a, and e to the power of 0, it's what? It's 1. So a is 1. Hence it becomes a is 1, and applying ln, we get this. And it becomes 2y ln of e is ln of x squared plus 1. Ln of e, it's log a, it's 1. And the y, it's 1 because log 2 8 is 3, y 2 cubed is 8. It's definition of log. So y is just this ln divided by this 2, it's 1, and it's the required solution. In general, you may keep constant and find constant at this step. In general, it doesn't matter. The next, find dy over dx in terms of x by differentiating your answer from b. So we need just differentiate this, and we can see that there is only one function but a more complicated argument. And if we consider ln function ln of x, is given in a data booklet, the derivative is 1 over x, but it's ln but a more complicated argument, and we should use a chain rule. And it says that we apply the same rule as for ln of x, and we write this argument instead of x, so it becomes 1 over x squared plus 1, and this 2 is just a constant. Constant by function, it's constant multiplied by the derivative. And derivative of ln is 1 over x and x squared plus 1 instead of x, but since it's x squared plus 1 instead of x, more complicated argument, we should multiply by this argument derivative. And this argument derivative is 2x, so it becomes 2x over 2 x squared plus 1, and it's x over x squared plus 1. The next. Hence verify that your answer to part B is the solution to dy over dx is x over e to the power 2y. What does it mean? It means that we need to show that this dy over dx, this in terms of x only, is equal to x over e to the power of 2y. And how to do that? So we should consider that x squared, let's just rewrite the previous result. Dy over dx is x squared plus 1, and using, so you can actually deduce that we need to show that x squared plus 1 is e to the power of 2y, and we can use actually this. A is 1, and you can see that e to the power of 2y is equal to x squared plus 1. Hence, dy over dx is x e to the power of 2y. As required. And that's all for this question.